there are 5 different types of bonds. Do you know them all? There's ionic bond. Ionic, so these are bond types. You probably should all write this down. There's ionic, covalent. Wait, why does anything bond in the first place? So they want to gain, lose, what's up with my pen? I don't know, lose or share electrons in order to achieve what? Get or achieve full, let's use that word stable. Stable octet. The word for it, the fancy schmancy science word for it is pseudo, I hope I spelled that right, noble gas configuration. EU. Thank you. Okay. Pseudo-noble gas. Fake noble gas. It's plastic surgery in order to look like a noble gas. Get some implants in your calves. Take a little bit off the nose, and you look like Brad Pitt, or I don't know who else you'd want to look like. But that's what atoms do. And in order to make these bonds, or when they do create these bonds, they gain, lose, or share electrons. There's different types of bonds, and we know them because they have these different properties. We're going to talk about these properties today. But so first of all, what are these other 5 types of bonds? Metallic. Metallic. And then the other 2 I'm going to mention are somewhat questionable, whether they are chemical bonds or something else. So we'll say also, sort of. Mr. Belmonte stopped in last hour, and I could actually ask him about this. I could say, so chemists and biologists debate about this type of bond. It's very important for life, and they debate whether or not it's strong enough to actually be considered a chemical bond or not. And those type of bonds that are important for life are, they involve water molecules, oxygen and hydrogen. Hydrogen bonds. Hydrogen bonds, which are really, they're an intermolecular. Inter means between 2 different molecules. Inter, not intra, not within the molecule. These are intra, or within. These are inter, or between 2 different molecules. Hydrogen bonds. And then, of course, there's James. You can't forget him. James Bond. Sorry, you have to give me, I have to just have a little bit of fun here. Thank you very much. We're going to focus on these 3 right here in class. Ionic, covalent, metallic. We're going to pretty much ignore these guys for the most part. I mean, you could say there's network covalent bonds here too, but I think we're going to call those actual covalent bonds. They're a special type, and they make diamonds and graphite. Well, not so much graphite, but graphite's pretty good covalent bond. Yeah, well, there's a lattice for a lot of things. All the things that are crystal have a lattice, so we call it a crystal lattice. So I have some crystals, thanks to Uncle Paul, that you can each take one and then pass the bag around. as you look at those crystals, those are actually salt crystals, pink salt crystals from the Himalayan mountain region. I wouldn't know if you did, but I would like to talk about what type of bond that is. Those crystals, no, but he bought it online because it's the best salt in the world, and your Uncle Paul is a foodie of all foodies. Like, yeah, so he, for Christmas, gave us this salt one year, and I didn't know what else to do with it but share it with you guys. So here it is. No, I have made Lily, I have used it as a brine, where I just put it in a jar of water, and then the water becomes salty, right? And I just use it for soups and stuff. It's not very good for baking. Anyway, these big salt crystals we're dealing with, tell me about them. What are the properties of these big salt crystals? These are ionic, aren't they? Everyone in my third hour, and who knows how many other people? We're going to pause right here after we